Hello everyone. As we are going to start a new lecture on theory of computation. This subject, theory of computation, is for fifth semester BE students who are studying under VTU. Okay. So let us start with the module 1. Okay. So in that module 1, there is main topic called as Introduction to Finite Automata. So we'll see about what is finite automata. Okay. So the finite automata is the theory which is the study of abstract machines or computing devices. Now, what are abstract machines? Abstract machines are the nothing but they are like a plans or the sketches before which we are going to have. Okay. So before building any devices, we are going to see about the working of those machines, how it is going to be worked or how it is going to be implemented, and what all faults or the errors we are going to get if we design further. Okay. So before implementing any particular machine or computing devices, we are going to study about the theory of that finite concept. So, and that too, the automaton or the machine which is having the finite number of states or the steps or the procedures. For that, we are going to apply this finite automata theory. Okay. So where all this automata will be useful. Okay. As this model is very useful in hardware and software. Okay. And we'll see what are the applications of this automata. So first application which I have listed here is it is used in the design and the behavior, checking the behavior of the digital circuits. Okay, and that too using the software. We can check the working or we can also design the digital circuits. Then it is used in the compiler design. So during compilation, we are going to see about the input text and we are going to break that input text into various logical units such as identifying the words or the punctuations, right? So we are going to have, there is a concept of in C programming language, it is mandatory that every sentence should end with a semicolon. So this compiler will help us to compile the particular syntax. And in designing such complex compilers, this automata theory will be used. And next it is used in the designing a software. Okay, and that software will be useful for identifying the word phrases or other patterns in large bodies of text such as collection of web pages. Say for example, nowadays we used to have search engines, right, like Google, Chroma and everything. So in such collections, the pattern matching is going to happen. So there, these kind of softwares are going to be designed using this finite automata. This automata or this finite automata concept will be helpful there. Next application is in building the software which will be verifying the system and having the finite number of states. So even there also this concept is going to be helpful. Okay. So now we got to know about what is finite automata and what are the applications of finite automata. Now we'll see how we are going to represent this. Okay. So now we'll see about the structural representation. Okay. So finite automaton can be easily described and understood using the important notations. Okay. And those two important notations are one is grammar and the one is regular expressions. Then, so these two notations play a very important role in the study of finite automata and their applications. So we'll see what is grammar or how grammar is being represented and regular expression how it is being represented. Okay. So firstly, grammar. So using this grammar, the corresponding software can be designed. And the style and notation used in grammar are entirely different when we are going to compare it with the its respective finite automata. So if we design the finite automata, there the states we are going to see. So states are nothing but we are going to have the structural representation in terms of finite automata. So it will be like this. Okay. So some transitions from one state to another state it is going to happen. But in the grammar, the representation is different. And in further topics, we are going to see how we are designing the grammars or how we are writing the grammars for the particular given situation. Okay. So this grammar can be implemented such as for designing the for statement in the if statement also this grammar can be designed very nicely. Okay. Next one is regular expression. So regular expression is a very short form. This is the combinations of small letter alphabets, let's say for example A or B or C and so on, with the combinations of union, closure, plus, like that. Okay. So we are going to see about some of these operators as well as some of these variables. So using the combinations of these two, the regular expressions are going to be represented. So this is the text strings and it is easily represented using regular expressions. So the pattern of strings which we are going to get or which is going to satisfy our condition, so that is going to be described using the regular expression. And this can be further described using the finite automata. In the further topics, we are going to see about the conversion from finite automata to regular expression and regular expression to finite automata also. Okay, but the style and notations are entirely different when we compare finite automata and the corresponding grammar. So it is completely different. But we are going to design an individual grammar. There will be an individual grammar. There will be an individual regular expression, and there will be individual finite automata representation for individual problem or the language I can say. Okay. So next we'll see about the next topic.